Hello children, welcome to the digital classes. Today we will be discussing about a new topic. Are you ready children? Yes. Observe your surroundings children. What can you see? You can see doors, windows, tables, chairs, television, laptop, radio, etc. What are they made up of? They are made up of certain materials. What those materials are called as? They are called as metals. So today we are going to discuss about the topic that is metals and non-metals. So what are metals? What are non-metals? How can you differentiate them? That we will be discussing today. Before going to start, let us first see what do you mean by a metal. Metals are nothing but solid materials. They are solid substances. So a solid material which is typically hard, shiny, malleable, fusible and ductile with good electrical and thermal conductivity are called as metals. What are the examples of metals? Iron, gold, silver, aluminium, steel, etc. So children, here if any substance is given, can you differentiate it whether it is a metal or a non-metal? So if you know some properties of the substances, then you can differentiate them very easily. So what are those properties? They are physical properties and chemical properties. So let us first discuss now about physical properties of metals. So here they are physical properties of metals. See children, observe them carefully. Hardness and softness. So metals are generally hard in nature. You observe their hammer is there. Hammer is very hard. Can you break it with your hands? No. So that hammer, it is made up of iron. So it is very hard in nature. In the same manner, you can see gold. It is also very hard. So we can say that metals are generally hard in nature. Now let us see the next one, that is lustrous. What do you mean by lustrous? They are nothing but shiny nature. So metals, they have luster. That means they are shining in nature. Examples: gold, copper, silver, iron, etc. Because of this lustrous property only, these metals are useful for making different types of ornaments and jewelry. Have you understood children? Now let us see the next property here, that is sonorous. So what do you mean by sonorous? For example, if anything falls, anything in the sense here, a bell is there or a violin is there or a guitar is there, strings are present to it, or a plate has been fallen on the ground, what do you get? You get a sound, isn't it? So that production of sound when an object falls on the ground, that is called as sonorous nature. So metals are sonorous. That means they make sound when they hit with an object. What are the examples? Bells, strings of guitar, etc. So this is also a property of metal. So metals are sonorous, they are lustrous and they are hard. Apart from this, they also have some other properties. Let us see what is that one. The next one is malleability. What do you mean by malleability? Here, have you ever went to the sweet shops children? So there over the sweets, some thin sheet is present. What is that thin sheet? It is nothing but it is made up of aluminium sheet. So what is that one? Let us see here. So malleability. Metals are malleable. That means they can be beaten into thin sheets with hammer. Example: iron, copper, gold, aluminium, etc. So the malleability, the nature of malleability, it can be seen in the metals. The next property is ductility. What do you mean by ductility? Let us discuss now. You know these metals, they are useful. For example, gold is there. It is useful for making different types of ornaments. So here they will be drawn into thin sheets. Not thin sheets, they will be drawn into thin wires. So these wires, the property of that transforming the metals into thin wires is called as ductility. See here children, ductility. Metals are ductile. that is they can be drawn into thin wires. Example, gold, copper, silver, iron, etc. So these are the physical properties. Not only these physical properties, one more important property is there for metals, that is they conduct electricity and they also conduct heat. So let us see now electrical conductivity and heat conduction. Conductors of heat and electricity. Metals are good conductors of heat and electricity. That means it allows the heat and electricity to pass through it easily. What are the examples here? Gold, copper, silver, iron, etc. So by the end of this, we can say that metals have different physical properties such as they are hard in nature, they are lustrous, they are sonorous, and they are malleable, they are ductile, and they conduct electricity and as well as heat. Have you understood, children? Now let us go to the next one, that is what are the physical properties of non-metals. Now let us see here the first property, that is hardness and softness. Non-metals, they are generally soft. Have you ever observed coal? You can break it easily, isn't it so? So here it consists of a non-metal called as carbon. So carbon, phosphorus, these are the non-metals which are soft in nature. Next, sonorous. Non-metals are not sonorous. What does it mean? That means it cannot produce sound when even hit with a hammer. Examples are bromine, fluorine, etc. And the next one is they are not malleable also. That means they cannot be brought into thin sheets. When we just beat them, they will break easily. Examples are sulfur, phosphorus, etc. And non-metals, they are not ductile also. What does it mean? They cannot be drawn into thin wires. Example, silicon, boron, etc. And apart from this, they don't even conduct heat and electricity. They are bad conductors. We can say that non-metals are insulators of heat and electricity. Example, iodine, neon, etc. So these are the physical properties of non-metals. So we have seen what are the physical properties of metals and as well as physical properties of non-metals. Apart from this, some exceptional cases are there. So what are those? Let us see now. Exceptional cases. Physical state. All the metals, they are solid in state, but mercury is a metal which is liquid at room temperature. Is it clear, children? Now coming to the luster property, iodine is a non-metal. Non-metals, they don't have lustrous nature, but iodine is a non-metal which is having lustrous surface, like that is nothing but shining surface, just like metals. The next one, hardness and softness. I already said that metals are hard, non-metals are soft, but exceptional cases are there. Here you can see alkali metals such as lithium, sodium and potassium, they are soft just like non-metals, whereas carbon in the form of a diamond is a non-metal which is extremely hard just like metals. Is it clear, children? Now the next one, electrical conductivity. So carbon in the form of graphite, though it is a non-metal, it conducts electricity. It is not an insulator, it is a conductor. So this is regarding about different physical properties and some exceptional cases. Only with these physical properties can we distinguish them as a metal and a non-metal. To some extent we can distinguish it is a metal or it is a non-metal by seeing physical properties. But if we study their chemical properties, it will be very clear for us whether the given substance is a metal or a non-metal. So let us see now what are the chemical properties of these metals and non-metals. Chemical properties. First one is reaction of metals with oxygen. So in this we will be discussing how the metals react with oxygen. For this we will be conducting an experiment. So what are the materials required for the experiment? Let us see now. The materials required for this activity are metal sample. Which metal sample we are taking here? We are taking here magnesium and spirit lamp and litmus papers. Why litmus papers are required? To know acidity and basicity of those oxides. Now here children, I will play a video, you observe it carefully how these metals react with oxygen. Now children, let us see a video here. You can see how metals react with oxygen. See children here, Observe it carefully. So for this you take a magnesium ribbon and you just hold it with the tongs and light the spirit lamp which is kept on the tripod and burn this magnesium ribbon in the flame. Observe it carefully, children. What happens? See here, the magnesium ribbon started burning. Are you seeing, children? Yes. What happens when magnesium ribbon burns? It will turn into ash. What is that? Ash. Now put that ash on a watch glass. Now put off this spirit lamp. Then take a glass rod, slowly powder that ash. What is that ash? It is nothing but magnesium oxide. Magnesium burns with the oxygen to produce magnesium oxide. Now pour some water into that magnesium oxide and slowly you mix it with the glass rod. What is this, children? It is magnesium hydroxide. Is it clear, children? Magnesium hydroxide. Now take a red litmus paper. Now put this red litmus paper into that magnesium hydroxide solution. Observe it carefully. Do you observe any changes? Yes. What is happening? Slowly the red litmus paper is converting into blue litmus. Red litmus has turned into blue litmus. What does this mean? This means that magnesium reacts with the oxygen and forms magnesium oxide, which is basic in nature. Is it clear, children? Have you understood? Now let us see how the reaction of non-metals with oxygen. What happens when these non-metals react with oxygen? Let us see it now. Yes, reaction of non-metals with oxygen. For this also a small experiment is being conducted. What are the materials required? Let us see here. The materials required for this activity are non-metal sample. We are taking here sulfur. A spirit lamp is needed and litmus papers are needed. And here, while conducting this experiment, you should be very cautious. Why? Because sulfur, when it burns, it releases some poisonous fumes which are dangerous for health. So you should be very careful while doing this experiment. Is it clear, children? Now let us see the video here how non-metals react with oxygen. Are you ready, children? Yes, here it is. Here you can see in this video, children, how non-metals react with oxygen. See here. So what is this? This is sulfur powder. So it is a non-metal. Take 1 spoon of sulfur powder and put it in a deflagrating spoon. Observe, children. Now on the spirit lamp which is kept on a tripod. Now burn this sulfur in a deflagrating spoon on this spirit lamp. Now what happens? You observe it carefully. Any changes you are getting? Yes. What is happening? It is slowly producing gases. When the gases are produced, immediately put it in a tumbler so that the gases should not evolve. See here, all the gases are being collected. So what is that? Sulfur reacts with the oxygen to form sulfur dioxide. Is it clear? Now remove the deflagrating spoon and pour some water into that. So what happens? Now sulfur dioxide which is present inside the tumbler, it reacts with the water and here results in the formation of sulfurous acid. Now take this solution in a watch glass and now put a blue litmus paper into that solution. Observe it carefully. What happens? See, children, what is happening to the blue litmus paper? It is turning into red. What does that mean? It means that it is acidic in nature. Have you understood? So now again you see from non-metals we have taken sulfur and metals. Metals you took magnesium. So we observed it carefully. Here metallic oxides, they are basic in nature, and non-metallic oxides, they are acidic in nature. Is it clear, children? So children, what can we finally conclude here? Observe it in this PPT. What is that? Metals react with oxygen to give oxides that are basic in nature, whereas non-metals react with oxygen to give oxides that are acidic in nature. Have you understood, children? Yes. Now let us go to the next topic, that is rusting of metals. What is that? Rusting of metals. Did you hear about this? What is rusting of metals? See here in this picture. This is a rusted lock and these are the rusted keys. How the rust is formed? Why the rust is formed? How can we stop from rusting? That we will see here. Iron rusts when it comes in contact with air that contains oxygen and moisture. So here iron, when it comes to the contact with the air which is having oxygen and moisture, it becomes rusted. So to avoid the rusting, what has to be done? It has to be painted. When it is painted, iron cannot come in contact with air, hence it does not rust. Not only iron, some of the substances, materials such as magnesium ribbon, it is also dull when exposed to air. Silver objects or silver jewelry, you know, anklets, they also becomes black when they are exposed to air. Copper vessels and statues, they also becomes green when they react with this air. So it is not compulsory that all the metals will be reacting with the air. Some of the metals such as gold and platinum, they do not react with the air, hence they do not rust. Have you seen, children, your gold ornaments? So will they get rust? Will they turn into black? No, they won't turn into black because they don't react. That metal do not react with the air which is having moisture and oxygen. Have you understood, children? So this is regarding about rusting of metals. Now the next one, reaction of metals with water. How metals will be reacting with the water, we will be seeing in this video now. So children, now we will be seeing a video where the metals, how they will be reacting with the water, we will be seeing now. So see this video, children. Observe it carefully. So here, what are the things required? The things required are water, phenolphthalein, it is an indicator, and sodium metal. Now take phenolphthalein, add 2 to 3 drops of phenolphthalein in the water. Observe it carefully, children. And now what is this? This is sodium metal. It is very reactive metal, so they cannot be left like that. They are kept in kerosene. Now with the help of tongs, slowly remove that sodium, put it on a filter paper, then you put it in the water. What happens? See here, the water is changing the color and the metal is moving here and there, making hissing sound. It is reacting. That means metals react with the water. So by this experiment we can say that metals react with the water. So this experiment is very dangerous, so it cannot be done by the students. It can be just seen when a teacher is performing this experiment. Why? Because sodium, it is a very reactive metal. Have you understood, children? So this is how the reaction of metals with water. Now let us see how non-metals react with the water. See here, non-metals do not react with the water. That is simple. Is it clear, children? So this is regarding about the reaction of metals and non-metals with water. The next we will be discussing about how the reaction of this metals and non-metals with the acids. See here, children, reaction of metals with acids. For this, a small experiment is conducted. Observe this experiment in this video, children. See, children, here we can discuss in this video how metals react with acids. Take some zinc metal and put it in a test tube. Now add hydrochloric acid, dilute hydrochloric acid into this test tube through its walls. Observe it, what is happening, some fumes are coming. A matchstick, when it is brought, it is just putting off with a pop sound, and just touch the test tube, what happened? It is hot. So when you observe it, it will be somewhat hot. So what does this finally say that? So what is that in test tube? It is zinc chloride. So here let us see what happened actually now. Metals, they react with the acids and they liberate hydrogen gas. So the metal which we took here is zinc, and the acid which we took is here is hydrochloric acid. So Zn plus 2HCl, when it undergoes reaction, it releases a substance called zinc chloride, and it liberates a gas called as hydrogen. Whether that gas is hydrogen or not, to prove that also we have observed that when a matchstick is brought there, it just put off with a pop sound, which shows that the gas which is liberated is nothing but the hydrogen gas. Is it clear, children? So this is regarding about reaction of metals with acids. Now let us see what happens when non-metals react with the acids. See here, children, non-metals, they don't react with the acids. There is no reaction of non-metals with the acid. Is it clear, children? So this is regarding about the chemical properties of metals and non-metals, that is how they react with the water, how they react with the oxygen, how they react with the air, and how they react with the acids. Is it clear, children? Let us now move on to the next topic, that is reactivity of metals. What is meant by reactivity of metals? See here, children, in case of some metals, the reaction is very fast. So those metals are called as highly reactive metals. Examples are magnesium, sodium, potassium, etc. Whereas the reaction is slow in case of some metals, and those metals are called as slow reactive metals. What are the examples? Gold, silver, copper, etc. That means reactivity is not same for all the metals. There are some highly reactive metals are there and some slow reactive metals are there. Now here let us see an experiment which proves the reactivity of the metals. So here a video is being played. Observe it carefully, children. See here, children. For this experiment you have to take 3 beakers. Name the beakers as A, B and C. Now in beaker A you put some 30 ml of water, and beaker B also, C also, you pour the same amount of water. So now the beakers are ready with the equal amounts of water. For the first A beaker you add copper sulphate. How much amount? 5 grams of copper sulphate should be added with the help of spatula. In B beaker also you add 5 grams of copper sulphate and mix it. See, children, mix it so that it can form a solution. Are you observing, children? So which color it is? Blue colored copper sulphate solution. In the third one you add ferrous sulphate powder of 5 grams and mix it with the help of spatula. In the first beaker you add zinc crystals. Zinc metal has to be added in copper sulphate solution. So copper sulphate and zinc in the first one. In the second one you add iron piece. Copper sulphate solution, iron piece has to be added. In the third one, iron sulphate solution, you take this copper rod and put into that one. Leave these reactions to occur. So observe in the first one what is happening. Zinc is reacting with the copper sulphate solution. You can see it clearly. Are you able to see some reaction is going on, children? Yes. Now slowly remove the water from the first one and observe it. At last what are present? Zinc is present, isn't it? Now take out the zinc from that beaker and put it in a watch glass. Is there any change in color? See, the first one which we kept is different color and this is different. That is, copper is deposited over the zinc. Is it clear? Now observe the second one. In the second one, copper sulphate, we kept iron nail. Now slowly remove the copper sulphate solution from this second beaker also. What is remaining at the end? Iron nail. Is it? Now remove that iron nail. Is it the same one? No, copper is deposited over that. So that is why it has changed its color. Have you understood, children? Now the third one, in the iron sulphate solution also we kept some copper one, isn't it so? So remove that iron sulphate solution slowly. What is present at the end? Copper rod is present. Slowly remove that copper rod. Observe it carefully. Is there any change, children? See, observe the video, children. Some of the metals, they will be replacing the other metals. So which metals will be replacing? Highly reactive metals, they cannot be replaced by less reactive metals, whereas less reactive metals can be replacing the highly reactive metals. So children, what happened? Let us see here. Copper sulphate, when it combines with the zinc, this has been formed into zinc sulphate and copper is formed. Whereas copper sulphate, when it reacts with the iron, iron sulphate is formed and copper is released. So that means here, highly reactive metals, they cannot be replaced by less reactive metals, whereas less reactive metals can be replaced by highly reactive metals. So by this, the conclusion is that all the metals don't have same reactivity. The reactivity will be different for different metals. Understood, ma? So this is regarding about reactivity of metals. Now let us see the next thing. What are the uses of metals? We have already seen what are metals, what are their physical properties, what are their chemical properties. Now we will be discussing what are the uses of metals. See here, children. Uses of metals. Silver foil is decorated on sweets. Aluminium foil is used in inner packing of food materials and toffees. Aluminium and copper mixture is used in currency coins, medals and statues. Zinc and iron mixture is used in making iron sheet. Agricultural instruments are also made up of iron. Apart from all these things, electrical appliances, automobiles such as cars, planes, satellites, aeroplanes, cooking utensils, machineries, decorative materials, all are made by metals. Why only metals are used? Because of their physical properties such as malleability and ductility. Already we have seen what is malleability. The metals are drawn into thin sheets. This property is called as malleability. What is meant by ductility? The metals are drawn into thin wires. That is called as ductility. Due to these properties only, they are used in various ways. Have you understood, children? Now let us see what are the uses of non-metals. See here, uses of non-metals. Sulfur, it is used in making fireworks, crackers, gunpowder, matchsticks and antiseptic ointments. Where is this sulfur found? It is found in onions, garlic, eggs, hair and nails. Activated carbon is used as a decolorizing agent and also it is used in water purification systems. Tincture iodine is used in medical purposes. So these are the uses of non-metals. Have you understood, children? So now a question for you. Human body is there. Whether it is a metal or a non-metal? Think it once. So try to get the answer for this question. Okay. So I hope you have understood this lesson. What we have learnt. A solid material which is typically hard, shiny, malleable, fusible and ductile with good electrical and thermal conductivity is called metal. Examples of metals are iron, gold, silver, aluminium, steel, etc. Now what is a non-metal? A material which is typically soft, dull, non-malleable and non-ductile without electrical and thermal conductivity is called non-metal. Examples are carbon, oxygen, phosphorus, sulfur, etc. But some exceptional cases are also there. Okay children? Now, oxides of metals are usually basic in nature, whereas oxides of non-metals are usually acidic in nature. Metals react with the acids and liberates hydrogen gas. Metals can displace each other according to their reactivity. Gold and platinum are the metals which do not react with air. Okay children, have you understood the lesson? And we will meet in the next
ఆరోగ్య మిత్ర. ఎందుకు ఊడిన పళ్ళ స్థానంలో కొత్త పళ్ళు అమర్చుకోవాలి? ఎన్ని పద్ధతుల్లో ఊడిన పళ్ళను అమర్చుకోవచ్చు? ఫిక్స్డ్ డెంచర్స్ ప్రాముఖ్యత ఏమిటి? పళ్ళు లేకుండా తినడం వల్ల మన శరీరం పైన కలిగే దుష్ప్రభావాలు ఏమిటి? పెరియోడాంటల్ డిసీజ్ లక్షణాలు ఏమిటి? దంతాల ఆరోగ్యంలో నోటి శుభ్రత పాత్ర ఏమిటి? ఇలాంటి మీ సందేహాలన్నింటికి డెంటల్ సర్జన్, ఇంప్లాంటాలజిస్ట్ డాక్టర్ రాజేష్ కుమార్ మాదిరెడ్డి సలహాలు, సూచనలు ప్రత్యక్ష ప్రసారం ఆగస్టు 26 శుక్రవారం సాయంత్రం 4 గంటలకు మీ TSAT నిపుణులు. సంప్రదించాల్సిన మా ఫోన్ నెంబర్లు 04023540326, 04023540726, టోల్ ఫ్రీ నెంబర్ 180042540339. ఆగస్టు 28 ఆదివారం ఉదయం 11 గంటలకు TSAT విద్యలో పునః ప్రసారం.
First question starts now. Which planet in our solar system is known as the red planet? Option A, Jupiter. Option B, Mars. Option C, Venus. Option D, Mercury. Your time starts now.